Imagine waking up to the realization that the entire planet is running out of food, all at the exact same time. After World War II, modern medicine drastically reduced death rates. People started living longer, and the global population surged at a rate humanity had never encountered before. But while the population was multiplying rapidly, the amount of food farmers could actually pull from the ground was moving at a crawl. This imbalance created a staggering global math problem. The absolute number of mouths to feed was rapidly outstripping the number of meals available. By the middle of the 20th century, developing nations were already struggling with severe food shortages, forcing them to rely heavily on massive grain imports just to survive. The traditional farming methods that had worked for thousands of years had hit a hard physical limit. Farmers simply could not squeeze any more calories out of standard seeds. Agricultural research shifted toward a new, daunting challenge: the logistics of growing enough calories for the entire global population. To avoid widespread famine, researchers began looking for a way to break through the biological barriers that restricted crop growth. During the 1940s and 50s, an agricultural scientist named Norman Borlaug began experimenting with plant biology to tackle this exact problem. Instead of traditional tall stalks, Borlaug crossbred a wheat variety that was short, thick, and sturdy. Standard wheats snapped under a heavy harvest, but Borlaug's shorter plants held significantly more grain without collapsing, provided they received enough water and fertilizer. These high-yielding varieties caused global wheat production to skyrocket in a matter of years, earning Borlaug the Nobel Peace Prize. By redesigning the architecture of the plant itself, he proved that physical limitations in agriculture could be broken through targeted science. By the early 1960s, India was heavily dependent on imported grain and staring down the barrel of a major agricultural crisis. To avert widespread starvation, scientists like Dr. M.S. Swaminathan took the lead in adapting these high-yield crop technologies, specifically for local Indian climate conditions. But the magic seeds required a massive infrastructure shift. Farmers rapidly adopted modern equipment like tractors, dug new irrigation networks, and applied heavy chemical fertilizers. The results were immediate. Agricultural productivity exploded across the country, eventually allowing India to produce enough major cereal crops to achieve self-sufficiency. This became known as the Green Revolution. By maximizing the absolute yield per acre, it pulled millions back from the brink of starvation. To see how science continues to solve our biggest physical challenges, hit the like button and subscribe to Agritech AI. But aggressive solutions often bring aggressive side effects. The exact chemical fertilizers that forced those massive yields began to severely degrade the biological quality and long-term health of the soil. And because these high-yield seeds required enormous amounts of water to survive, aggressive pumping led to the severe depletion of natural groundwater reserves. The industrial methods that successfully fed humanity in the 20th century were slowly stripping the Earth of its capacity to do the same next century. Recognizing this decline, Dr. Swaminathan championed a necessary evolution for global farming, the Evergreen Revolution. The mandate is highly specific: increase agricultural production to feed a growing planet, but do it without causing permanent damage to natural resources. While the Green Revolution on the left was strictly focused on volume, the Evergreen Revolution is a closed loop, emphasizing a biological balance between the environment and the harvest. It relies on maintaining organic soil nutrients, maximizing the efficiency of every drop of water, and actively protecting local biodiversity. The standard for agricultural success shifted from purely immediate yield to long-term sustainability, ensuring that today's harvest does not destroy tomorrow's ability to grow food. Achieving this delicate biological balance on a massive global scale requires precise intervention. Farmers are now adopting modern tools like automated drip irrigation and AI-based monitoring, which deliver exact amounts of water and nutrients straight to the roots with almost zero waste. Smart farming technologies, including agricultural drones, sweep over fields to monitor crop health with pinpoint accuracy, allowing farmers to apply treatments only where they are absolutely needed. The Green Revolution taught humanity how to produce more food. The Evergreen Revolution is teaching us how to produce it responsibly. But crop farming is only one piece of the puzzle. In our next episode, we'll explore the white, blue, and yellow revolutions and how these movements applied similar scientific logic to milk, fish, and oilseed production.